Hi everyone, and welcome to Creation 101. Today I'm going to talk to you a little bit about how the universe started and why the most important element in life may not be what you think it is. If I were to ask you what the most important element in life is, you'd probably say oxygen, or maybe carbon. People who don't know what an element is might say water or air. And to be sure, all of these are very important in sustaining life. But where did they come from? That oxygen you're breathing now, where did it come from? To answer that and to understand why none of this would exist without iron, we have to go all the way back to the very beginning. The best currently accepted scientific explanation about how the universe came into existence is called the Big Bang Theory. It is believed that a small, tiny, infinitely dense spot exploded, creating the whole universe. But what came from that explosion? Not Earth, and definitely not us. So, you might recognize this as the periodic table of the elements. It was designed to torture students in chemistry class, yet it contains the names and the makeup for all the elements in the universe. Every single thing that exists is made up of some combination of these elements. They make up all matter, and yet none of them came out of the Big Bang. So what the heck did all this come from? And what does all this have to do with iron? It is believed that what did come from the Big Bang Theory are the elementary particles. None of these are important to us right now except for the quarks and the electrons. The quarks form the protons and the electrons that we all know and love. A couple of minutes after the Big Bang, those protons and neutrons join together. After grabbing electrons zipping around, they form the first atoms of hydrogen. After all, it's hydrogen, one proton, one neutron, and one electron. The Big Bang is believed to have created all the existing hydrogen in the universe, as well as bits of helium and traces of lithium. And that's it. No carbon, no oxygen, no metals, nothing. But by understanding what comes next, we get a brief look into the beauty and majesty of the design and architecture that was programmed into this incredible universe. The infant universe had huge clouds of hydrogen gases floating all over the place as the universe expanded. And when I say huge, I meant galaxy-sized clouds. Clouds this massive generate a lot of gravity. Eventually, that gravity will crush the cloud into a giant ball. And then, that giant ball's core, the temperature and pressure will be so high in the core that the hydrogen atoms will smash together to form helium. Helium is 2 protons, 2 neutrons, and 2 electrons. The smashing of hydrogen atoms together to form helium is called fusion, and it's like a million billion nuclear bombs in the core blowing up at the same time. So, as gravity crushes a cloud from the outside in, explosions in the core try to blow the whole thing up, and a perfect balance is created between the two forces, and literally, a star is born. A star will burn brightly for millions or billions of years, depending on its size, before it eventually runs out of hydrogen and becomes this 2-star layer, and we have a core with just helium. And with a size that massive, more bigger than the sun, weird things happen. Without any hydrogen in the core, the great furnace shuts down, gravity again wakes up and starts crushing the star down smaller and smaller. And again, the temperatures and pressures in the core raise so high that it smashes the helium atoms to form carbon. For the first time ever, carbon atoms appear in the universe, and then we end up with this 3-layer star. If one of the layers were to run out of fuel, the process repeats itself. Once helium is done, the carbon will smash together to form neon, which will smash to form oxygen, and then smash to form silicon. And then we get this 6-layer burrito. By looking at this, just the oxygen layer in the core is bigger than the sun. So, this star creates everything necessary for life. Hydrogen and oxygen combine to form water. Carbon molecules will eventually create humans and life. But none of this will do any good when locked up in a star like this. Nature has to somehow find a way to get all these precious elements out to the 4 corners of the universe. And for the final step, When the oxygen in the layer in the core runs out, the star will fuse silicon into iron. Now, anyone who could will tell you that iron is great at sucking up heat and not letting it go. Another problem is that iron is very stable, and conditions have to be so crazy in order for it to fuse itself to something else. And so, the star, which desperately needs heat and energy to survive, finally loses its war with gravity. The furnace shuts down, and gravity crushes the outer layer so quickly and with so much force that the core becomes unstable, recoils, and explodes. The explosion, called the supernova, releases all the crucial elements the star once had. Also, in that split second, conditions are so crazy that heavier elements like gold and silver are created. So next time you cook dinner, remember that billions of years ago, the pot you're using killed a star, and if it hadn't, none of us would be here today. And for those of you who think science has no business stepping on toes of religion, I'd like to leave you with a final thought. This is a mass of a proton. For all intents and purposes, this is pretty much zero. But if you were to take one of these numbers and increase it or decrease it by one, let's say, for example, you turn a 6 into a 5 or a 7, you'll blow up the whole universe. The particles have to come in exactly the way they did for the system to develop properly. Luck? I think not. By the way, for more information on this topic, Science Channel has a great series called Space's Deepest Secrets. There's an episode called Strangest Alien Stars, which is worth a look. Thank you.